Biodiversity loss is defined by a loss of life on Earth at various levels, ranging from reductions in the genetic diversity to the collapse of entire ecosystems. Living near the Texas Gulf Coast for the past 20 years, I have seen many environmental changes throughout the years, including a severe loss of habitats and species populations. The Texas Gulf Coast has one of the biggest hypoxic zones. This oxygen dead zone affects all the fish and other organisms all the way down the food chain to land-based organisms and humans. This leads to devastating issues with conservation, ecology, and even down to the fishing industry and other industries that rely on the Gulf for business. As chemicals are spilled into the ocean, they deposit nitrates and phosphates, and this causes a decrease to the salinity of the water. As the salinity decreases, it leads to an increase in phytoplankton. These events are referred to as harmful algal blooms or HABs. HABs can occur for a number of different reasons, although a common one is an overabundance of nutrients, which is often due to excessive terrestrial runoff of fertilizers or other nitrogen and phosphate containing materials. These conditions lead to an explosion in algal populations that can change the color of the water if the cells are in high enough concentrations. When this entire algae eventually dies off and sinks, their decomposition uses up the dissolved oxygen in the water, leaving anoxic or hypoxic conditions that can lead to the mass die-off of fish and invertebrates, completely altering the food webs of that area. Without an update in policy, both environmental and industrial, we could continue to see oil spills, fertilizer runoff, and human interactions that could increase the hypoxic area in the Gulf. Some current and past management practices to prevent this is the Clean Water Act. This was established in 1972. This act regulates the discharge of pollutants in water. It requires permits be obtained for any pollutant discharge. They measure water quality and ensure that there is clean drinking water. Hypoxia Task Force. This was established in 1997 as a joint federal and state effort with a goal of reducing nitrates and phosphates. They were focused on research as well and creating a program based on nutrient reduction. However, it has not quite gotten off the ground due to lack of funding, inadequate scientific knowledge, and the uncertainty of where exactly the pollution is coming from. Utilizing no-till farming methods. This is a method of farming that uses discs that slice in the ground and deposit seeds. This type of tilling reduces soil erosion and drastically reduces the amount of fertilizer and chemical runoff, allowing surface water to be absorbed by root systems versus washing out the soil and creating surface runoff. The Cartagena Convention. This is the only multilateral agreement in force that governs the Gulf of Mexico and the Caribbean to protect habitats, providing natural resources. They follow oil spill protocols specialized in protected areas and wildlife, and collect data on land-based sources of pollution. They cover many different types of marine pollution, including runoff like we have discussed previously, pollution runoff from ships, illegal dumping, and air pollution. While researching past and current practices for mitigating the effects of fertilizer runoff in the Gulf, I came across an article by the USDA about no-till farming. Working with the Natural Resources Conservation Services, farmers apply a system of conservation strategies to keep valuable fertilizer on the land and out of nearby waterways. Filter strips move row crop operations away from streams and function as collection centers for nutrient runoff. Cover crops reduce soil erosion and hold nutrients in place. No-till practices also reduce soil erosion and improve field level water infiltration capacity. Tillage turns the soil, while no-till uses discs to slice in the ground and slip seeds into the narrow slice. There is no soil disturbance of substance in no-till. No-till systems are excellent at reducing erosion. Intact soils also maintain root channels that facilitate greater water infiltration and storage. No-till tends to increase soil organic matter in the top several inches of the soil. No-till also tends to require much less fuel and labor expenses because it does not require all the energy needed to push farm equipment through the soil. Since the no-till method keeps roots channels and does not interrupt or erode the soil, if farmers lay down fertilizer, it keeps it in the crevice where the soil was placed and absorbed directly into the root system of the plant. I feel that this method could in turn reduce some of the fertilizer runoff in the Gulf of Mexico. My swag idea is to make a shareable social media file for Facebook, Twitter, Instagram, etc., with links to information about the harmful algal blooms caused by fertilizer runoffs and increased nitrates and phosphates. I could realistically use this as a bumper sticker or button as well. However, I feel in this day and age, social media is the fastest way to spread a message. I came up with a slogan for my campaign of toss fertilizer aside and prevent red tide. On Facebook especially, you could be added to groups for practically any topic. If I could gain access to a few farming pages, I would share it directly with my intended audience. The best way to start and try to get a message across would be educating people on why it is necessary to have some type of action on controlling fertilizer runoff and how it affects the environment and the species living in these affected areas. This swag would appeal to farmers as the agricultural farming is what attributes to this hypoxic dead zone. I would explain to them that a lack of policies regarding fertilizer runoff, oil spills, and other environmental hazards has led to an ever-growing dead zone in the Gulf of Mexico, causing mass biodiversity loss. As chemicals are spilled in the ocean, they deposit nitrates and phosphates, and this causes a decrease in the salinity of the water. One possibility to help correct this issue is exploring other fertilizer options that may have lower levels of nitrates and phosphate, or also coming up with an irrigation plan that would lessen the runoff in the waterways and keep the chemicals on their land. I hope this presentation has been educational and informative and will help put in some motion on some positive change for the hypoxic zone areas in the Texas Gulf Coast. I have included a link to the source of my research, and I can have any additional information available if you have any additional questions.